Okay, today we're going to do slope-intercept form part 1. That's student handout 3 in your notes packet. So, Xander has biked 2 miles so far this week and plans to bike an average of 6 miles each day over the next several days. Xander wrote the equation and created the graph to represent x, the number of days, and y, the total number of miles traveled on his bike. Okay, so we need to find the slope of the graph. Okay, so to find the slope of a graph, we find the rise over run. We could also use the slope formula if we wanted to, but it's probably just going to be easier to take 2 points and then count the rise and run. So I see a point right here at 1.8 and a point right here at 2.14. Okay, so the rise is the vertical change or the up and down change, how much it goes up from point to point. So from here to here, we have 8 and 14. Okay, so that means our rise is 6. Then we find the horizontal change, that's the run from point to point. So we're going to go from here to here. Okay, that is from 1 to 2, which means our run is 1. So our slope, or m, equals 6 over 1. And 6 over 1 is just 6. Okay, where do you see this in the value of Xander's equation? Well, if we look at his equation, we see that there is a 6 right here. Okay, that 6 is the coefficient of the variable. So that's where we see it. Okay, the coefficient of the variable x. Okay, now down to B. What value does the graph touch on the y-axis? Where do you see this value in Xander's equation? Okay, well, first thing we do is remember what the y-axis is. The y-axis is this line right here. Okay, the up and down axis, the vertical one. Okay, and here is Xander's line right here. To figure out where those 2 points meet, we just look at it and it's right here, and we know that that value is 2. So we know that the graph touches the y-axis at 2. Okay, where do you see this value in Xander's equation? Well, let's go back to his equation. I see that there's a 2 right here. Okay, that is the constant term. So the constant term in the equation is 2. Okay, Xander's equation is written in slope-intercept form, which is described below. So here's slope-intercept form. Slope-intercept form, or y equals mx plus b, is one way to write the equation of a linear relationship. The y-intercept of a graph is the value of y where the line crosses the y-axis, or when x equals 0. Okay, so let's use that to fill this out right here. So m is always going to be your slope, and it's always going to go right there in slope-intercept form. Okay, the things that aren't going to change are the y equals x. Those are always going to be in the same spot. The m and the b are always going to be in the same spot as well, but those are going to be replaced with number values. Okay, and b is your y-intercept. Okay, so we are going to use the given information to write an equation of the line in slope-intercept form. So let's go to number 1. Okay, my slope is -9. My y-intercept is 2. So we know that it's going to say y equals mx plus b. Well, we know that m is the slope and b is the y-intercept. So that's what we're going to fill out on these lines right here. My slope is -9, so that -9 is going to go right there. My y-intercept is 2, so my final equation is going to be this right here. Y equals -9x plus 2. Okay, let's go to number 2. All right, so we know that it's going to be y equals mx plus b. Okay, y equals x Those are always going to be the same, okay? So my m is 4.5. I know that that goes right there, so I'm going to put 4.5 right here. My b is negative 10, and I know that that goes right there. Now, adding a negative is the same thing as subtraction, so I'm just going to put minus 10, and it's going to mean the same thing. This is just the simplest way to write it. Okay? Now we're going to go to number 3. A line has a slope of negative 5 and passes through the origin. Well, the origin is at point 0, 0. So when x is 0, that gives you your y-intercept. So this value right here tells me that my y-intercept is 0. Okay? So my slope is negative 5, so that's going to look like y equals negative 5x. And since my y-intercept is 0, I'm just going to leave it like this. Okay? Because plus 0 isn't going to change anything. Now we're going to complete the table below by recording the slope, the y-intercept, and a sketch of each linear equations graph. So this first one says y equals x minus 5. There's no number here, but we know that if there is no coefficient in front of a variable, it has an automatic or invisible coefficient of 1. So I know that my slope is 1. M equals 1. My y-intercept is my constant term. My constant term is right here, that's negative 5. So my y-intercept is negative 5. So I'm going to put b equals negative 5. Now, it doesn't want you to graph this exactly, it just wants to see what it would look like. Okay, so my y-intercept is going to be somewhere here, okay, because it's negative, and my slope is positive. So I'm just going to draw a line like this, and that's good enough, okay, because that shows a positive slope. All right, moving on to the next one. Y equals 3x. Well, we know that the m goes before the x, so that means my m is 3, okay? I don't have anything where a constant would normally go, so that means my y-intercept is 0, okay? So that means my y-intercept is going to be here, and that's going to be a positive slope. So I'm just going to draw a positive slope through the origin, and that's good enough, okay? Last one. This negative 5 is my coefficient. It comes before my x, so I know that m equals negative 5. My constant term is positive 7, so that means that my y-intercept is 7. So whenever I do this, I'm going to put my y-intercept somewhere up there, and this is going to be a negative slope, so it's going to go down from left to right. So it's just going to look something like that. Okay? And that's as simple as you have to go with those because I didn't want it graphed exactly. So, moving on to number 5, that's on the back of the front page of Student Handout 3. For each graph below, record the slope, y-intercept, and equation in slope-intercept form.